All right, so we have an application problem here, another distance, rate, and time problem, and this is dealing with upstream and downstream. You'll often run into upstream, downstream problems that want to know the current. That's not really what's happening in this case because they describe upstream in terms of downstream. Notice Cassius drives his boat upstream for 45 minutes. It takes him 30 minutes longer to return downstream. His speed going upstream is 3 miles per hour slower, which makes sense, than his speed going downstream. Find the upstream and the downstream speeds. Now, what is pretty consistent about all these distance, rate, time problems is that you have two different situations going on. And in this particular problem, we have an upstream situation, and then we have a downstream situation. So my goal is to think about all of this, upstream and downstream, in terms of distance equals rate times time. So first let's do the upstream. He goes for 45 minutes, so our time is equal to 45 minutes, okay? Now, here's something I want you to know. Look at this. We're talking in miles per hour. So the 45 minutes isn't going to cut it. We need to turn that into hours. Anytime you have minutes to turn it into hours, you need to divide it by 60. So I'm going to divide this by 60, and I'm going to get rid of the minutes. And now this is in terms of hours. Okay? So the time is 45 over 60 hours. Now we know that reduces to 3/4, right? Because 15 goes into both of those. And 45 minutes is 3/4 of an hour. That's another way to think about it. So our time is 3/4 or 3/4 of an hour. Do we know anything else? Do we know the rate? Do we know the distance? Well, let's keep reading. He drives his boat upstream for 45 minutes. It takes him 30 minutes downstream. So let's stop. We've used the 45 minutes upstream. And let's use the 30 minutes downstream. Now that's time in the downstream area. So we're going to have a distance equals rate times time. So we know time here is 30 minutes. Once again, we're not supposed to write it in terms of minutes. We're supposed to write it in terms of hours. So over 60, now it's in hours. And of course we know that's 1/2 of an hour. So my time, my T, is 1/2 for downstream, back to 3/4 of an hour for upstream. Okay, now his speed going upstream is 3 miles per hour slower than his speed going downstream. Now notice we don't know either of the speeds. We just know upstream is slower than downstream by 3 miles per hour. So downstream, I don't know what it is, but I'm going to call it R, because again, upstream is in terms of downstream. So my R for rate, I'm just going to call it R. But back for my downstream, my R here is going to be the R that's over here minus 3, and that's that 3 miles per hour. Now, when you have your two situations, another problem we did, you might add upstream plus downstream, or, well, it wouldn't be upstream and downstream, but you might add your two situations together. Like the other problem we did, the two situations added to be 95 miles. Well, what's going on is our distances are the same. Like if he went upstream for 45 minutes and then he turned around and went back downstream to his same starting point, the distance is what matches. And that is the key to this problem. So distance is the same. Okay? Now, since distance is the same, I can say that this D is equal to this D, right? So D is equal to R times T. So now I'm using my formula. So back to the blue scenario, the upstream situation, D is equal to R, which we called R minus 3, times our time, which is 3/4. For the downstream situation, D is equal to also R times T, but the R here we called R, times my T is 1/2. And since these distances are equal, what I'm going to do is set R minus 3 times 3/4 equal to R times 1/2. Now I'm going to make that look better, and I'm also going to go to another page so I have more room. So here we are. I rewrote our equation. Now, we have fractions here. I don't like them. You don't like them. Nobody likes them. So let's clear the fractions. So to do that, what you do is you pay attention to all your denominators. I got a 4 and I got a 2. What's the least common denominator for 4 and 2? Well, 4, right? So what I'm going to do to clear fractions is I'm going to multiply each side by 4. So I'm going to multiply this side by 4, and I'm going to multiply this side by 4. Now, why does that help? Well, this 4 cancels with that 4. I just moved my screen. Apologize about that. Okay, I fixed that mess. So this 4 cancels with this 4. And notice I'm still left with r minus 3 times that 3. Okay, are you allowed to do that? Yes, you are. So right here, this 4 cancels with this 2, but now that still leaves a 2 up there. So what does that leave me with? It leaves me with this r still there, and then 1 times this 2 is just times 2. Now we need to distribute right here from the back. So I have 3r minus 9 is equal to, now on this side, instead of writing r times 2, I'm just going to write 2r. Now I'm trying to get the r by itself, so my next step is I'm going to subtract 2r from both sides. Now that leaves me in a weird spot. I've got 3r minus 2r is 1r, which is just r, minus 9 equals 0. But I'm still trying to get the r by itself, so I'm going to add 9 over, and that gives me r is equal to 9. Now that's my r value. But remember, what they ask is what is upstream, right? Stream, and what is downstream. Okay, now upstream, if we go back and look at the original problem, upstream, and I look at my rate, it's r minus 3. Now my r was 9, so upstream is going to be 9 minus 3, or 6 miles per hour. Okay, so remember r is, again, or I should just say rate for upstream, because it was r minus 3, which is going to be 9 minus 3, which is 6 miles per hour. Go back and look at the original again over here. Downstream, now our rate in downstream, I should just call it rate instead of r, but I mean rate right here, is r. It's the actual r that we got. So here I can say, you know, our rate is equal to just r, and our r is 9. So 9 miles per hour downstream. And notice those are 3 apart. I think if you ran the numbers, if you went 6 miles per hour for 45 minutes, that would give you the same distance as if you go 9 miles per hour for 30 minutes. I'm not going to check that because my video is running out of time, but I'm pretty sure that'll work. So I hope this helps you out, and you have a wonderful evening.